Welcome back, everyone. Announcements first. Your quiz is going to be open at the end of the lecture. You have 24 hours outside of the lecture. Due date tomorrow. Please be sure to complete your first quiz. Easy one. 13 questions, in which 10 are all about lecture 1, the syllabus. So I just want to be sure that you read the syllabus and you're aware of the rules. 3 questions, maybe 4 in some of the cases. So 3 or 4 questions, 9 or 10 about lecture 2 and 3. And to be honest, requirements, functional requirements, non-functional requirements, what's a requirement, what is a need, and so on. So 3 or 4 questions about that, content, and the others just read the syllabus. Regarding the question, both, you can review that in the lecture 1. There are going to be quizzes all about topics, and they are going to be not easy. But this in particular, 10 questions, are used to know that you read the syllabus. Okay, so check. Okay. Good. So you have the quiz, and I am going to talk about an assignment by the end of the lecture. But before the assignment, we talked in the previous lecture about common errors when you are trying to create requirements, common errors when you create these stories. I asked you to create the stories for the Pac-Man video game. Something that I reviewed with you guys was your submission. And in your submission, errors. You have these slides and the video with all these red rectangles, and they are pointing out something is wrong. So the question at the end, the question for today is, well, making errors is easy. One way or another, you can do a mistake. What we do in order to create the requirements for your project, for any project, correct. Okay. Following with the Pac-Man, step number 1. Step number 1, when you have a project, when you have a meeting with the customer, when the customer is explaining to you what to do, like I did with the Pac-Man, or I can do with another one. After you talk with me, after you talk with the customer, what you can do is a meeting with your team, or even you can do it in the same meeting with the customer. Try to create a storyboard of what the software is going to do. Try to create this description, like what is going to happen from the beginning to the end. What are all the different combinations or paths that could happen or should happen in the software? In other words, explain the story from the beginning to the end, to your team, to yourselves, to the customer. Put this story in some kind of storyboard format. What I am asking, if I am telling you to do a storyboard, 2 things. Step number 1, if you're doing a storyboard, the first thing that you need to do is to identify the actors. Who is going to do what? Who should do which part? That who is going to interact with another who? Now, I am not talking about the actors in the team. I am not talking about the actors, the stakeholders. I am not talking about the testers, the developers, the customer, the marketing. No, I am talking about the actors inside of the software. I am talking about these elements in the software that are supposed to be working. Help me with the Pac-Man. Do we have actors in the Pac-Man? Who are the actors in the Pac-Man? What can I consider actors in the software Pac-Man video game? Yeah. I am going to take the two of the three that you mentioned. Number one, for sure, one of the actors, one of the elements that do something in this problem is the Pac-Man. Is the Pac-Man video game, so for sure Pac-Man should be involved. However, Pac-Man is an actor, yeah. And if we talk about Pac-Man, it's exactly the same that talking about the player. Think about it. The player and the Pac-Man, they are the same. The Pac-Man is going to move. Well, the player is the one moving it. The Pac-Man is going to die. Well, the player is the one that died. He's not going to be able to play anymore. You can think about the Pac-Man. You're right. You're thinking about this cartoon version. You can think about the player, and both are correct. You are talking about exactly the same. The player is going to move left, right, up, down. The Pac-Man is moving up, down, left, right. We're talking about the same actor, the Pac-Man or the player. The second actor that you mentioned, and obviously the counterpart, is if we have the Pac-Man, we have the ghost. Or some of you call this, well, the enemy in your stories. Someone else called, well, the system, the artificial intelligence. It doesn't matter which of those names you use in your requirements before. If you read what we reviewed in the previous lecture, all of you are talking about the same. These guys then need to move and go and attack the Pac-Man and make the game interesting. Those are the two actors that are playing here. The system and the player, or the Pac-Man and the ghost, whatever. Two actors, two things working for this software. Exactly, they are the same. Two actors, you can name it Pac-Man, you can name it player, they are the same. We're talking about the same. Yeah, good. So you mentioned another one, the dots, right? We're talking about here, identify actors. And a key characteristic of the actors is these guys that do something, acting. Something that we have here in particular for the dots is they do not really do something. And that is the only reason because I am not going to list the dots as an actors. Yeah, we have dots in the screen and we have the maze on the screen. They are elements, but those elements, according with the description that we have of the game, they are not doing actions. They are not involved in a particular kind of functionality. You can be thinking like, well, when we eat one of the dots, the score is going to increase. Yeah, but the one that is going to eat and therefore increase the score is the Pac-Man, not the dot itself. So with that rationale is like, well, looks like the only elements, the only actors doing something, creating action, these two. All the others, including the maze and the dot, there are just static elements there. Good. So step number one, you have a problem, identifying your problem, the actors. Common actors. Always, 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 you are going to have a user for the system. The user is going to do something. By the way, another name here for the player is the user. Sometimes the user is going to have a fancy name. Sometimes it's not. If we think about, for instance, Canvas. In Canvas, which are the actors? If I ask you to go and describe the requirements to create a piece of software similar to Canvas, actors. Elements that do some kind of action. Okay, I like that. With Canvas, you can think in like, well, we have users. Someone is going to use. We do not call it players because it's not a game. However, you are thinking like, well, we have users, but we have students, we have professors, and they have different options, different actions. So two different things. Actors for the Canvas, student, yeah. Professors, yes. You do not know the details, but also there are TA as an actor because there is a particular role or a particular path, set of actions that someone with the role of TA can have. There are graphical designers. There are people that have access used to add graphical elements and so on. Users. Let's keep use students and professors. Now you are thinking about the next one. On Canvas, we have these two, student and professors, like the replacement. But do we have something similar to the system on Canvas? The equivalent to this AI, or, well, we do not have enemies, but the system on Canvas? Any kind of activity, action that the system is going to do is not done by a professor, is not done by a student, but something else? Yes. Someone is going to do the auto-grading of the quizzes. Someone posts the announcement early in the morning. It's not the TA, it's not the professor. The system is the one that I tell the system to post an announcement, the system do that later. There is this intelligence system, backend, something happening that is not in the control of the user. So on Canvas, you can have professor, student, and the system. You cannot use fancy names for the system in the same way that we use here, the ghost or the enemy. So elements in the system that could be people, but also the computer itself doing something, doing the actions. Identify those elements and we move forward. Question in the chat regarding the pills. Things with the pills, and in particular with the Pac-Man, these guys are not doing anything. Tell me, that are going to move, are going to kill someone, are going to show something? If you ask about, they are going to do something, and the answer is no, they are there, and we never know why, or they are there just because the Pac-Man is going to eat them. They are no actors. Elements in the system, part of the system. They do not have a particular useful name. So elements that do actions like this, people or the machine itself, actors. Good?
Can I ask a question?
Yeah, please.
Yeah, so I just want to make sure, but I would assume that it's possible for there to be multiple systems, not just because in a game there could be multiple enemies, but practically speaking, just like for like a web application, maybe like with a bank or something, you might need to make a request to a third party. Like, so maybe there's one system that handles this, but a third party you have to reach your software out to do that. And that would be multiple system entities, correct? Or actors, sorry.
Yeah. It's the same idea that with the actors, and it's a good point. With the actor, I am thinking about people. And for instance, for Canvas, I separate two categories of people, professors and students. But with the system, it's the same. You have the system, and in this case, for the Pac-Man, it uses the IE, the enemies, whatever. But we can think about Canvas. And in Canvas, it's not the same system. The one that, for instance, grade your quizzes, and the one that, for instance, send you a copy of the announcements by email. Canvas do that, right? Someone is sending you a copy of all the announcements by email. And that someone, that actor, the one handling the email, the one maybe connecting with the service of the email, whatever, that guy, that actor, that part of the system is not the same that the one that do the grading of your quizzes. It's the same canvas, but inside of the canvas, inside of the system, there are these subsystems, different actors, different guys working inside of the canvas doing different things. Yes, so that is possible. Good? Okay, we have the actors. After we have the actors, step number 2. Put your actors and think about which actions each of the actors are involved. In this point, I am sure you remember the use case diagrams. The only reason because the use case diagram exists is because for the people, for us, it's easier to think in a graphical way. It's easy to do draws, lines, circles, and so on, that writing a document for most of us. I mean, the theoretical background is for the humans. We are visuals. So using a use case diagram after you identify your actors, well, tell me for each of the actors, which are going to be the actions, the things that that actor is going to do or that actor is going to ask for. It doesn't matter. Is usually when you think for the perspective of the user, the player, you are thinking what the player is going to ask for, what the player is going to request from the system. And usually you can think about the system like the provider, right? Like the one that is going to do things. Just because we think about the human asking, the computer providing. It doesn't matter. Either I provide something or I ask for something, but those are my actions. Connect the actors with those actions. And you are going to have for the Pac-Man something like this. And I put this like a picture of a draw with pencil because it's not correct yet. But this is the first idea that a group of the students provide. Like, well, if you think about the player is involved in moving, eating. Notice that a lot of things are missing here. Initial ideas, moving, eating. For the enemy, a lot of things are missing there. But the first ideas of these students is, well, the enemy, the ghost, they are going to eat, they are going to follow, chase things, run away. Big picture of the storyboard. You need to start with something. And obviously this first version, with your knowledge of 360, this is not correct. This is not a final diagram. This is something that, well, you cannot use only one word. They are not clear, etc. You start with something. When you start with something, you can show to your team, you can show with the other people working with you, and then you can start thinking about, well, what is missing here? Moving? How? Eat? What? Why? Run away? How? Where? You or someone else is going to ask for details. And answering those questions, what, why, where, how, without answering technical things. You're not trying to program this, not yet. It's just trying to understand the process. You ask questions and you're going to have a bunch of answers. A bunch of answers like the one that you sent me as the previous assignment, like the one that we reviewed before. All these statements that you shared with me about something. A list of what we think was requirements, and they were not. With all those ideas, brainstorming, you put your ideas in some kind of document, in a whiteboard, in a piece of paper, whatever. For each of the ideas, you can do what we did in the previous lecture. Invest. That idea that someone mentioned, like eat, that is independent from other ideas. That can be implemented without mixing with other things. Wait, that idea is something that is something valuable for the customer. But moreover, it's valuable for the customer, and the idea itself is talking about a functionality, not about how that functionality is going to be implemented. It's not technical. Can I read that and estimate the cost of the time or the lines of code, whatever? Provide an estimation in some way of the work that I need to do to complete this. And remember, this is just to be sure that you are understanding what you are going to do. Is it small? Can I finish this in 1 week or 2 weeks? One person only? Can I test it? Like done or not done? You take your ideas, your brainstorming, and you ask this, and if they pass this, those are good candidates for being here in the ovals. The ovals are your requirements, remember? These ovals are your functional requirements. And everything that you put inside of an oval should have this as a feature. If I read this and I go here, I'm going to identify that there are things that are unclear. Eating. I am going to identify that there are things that need more information. Run or chase. Because there are questions about how, what. Okay, I know that you want this, is the big picture, but I need more. And suddenly, in some point, the evolution is going to be like, well, what about this? Compared with the previous one, you have more things that are circles. Compared with the previous one, now you identify like, well, wait, in the previous one, there is no mention of the maze. And I am sure that in the brainstorming, someone is going to mention, hey, wait, all this is true. We have an enemy, we have the player, both want to eat, both want to move, but we haven't mentioned anything about drawing something on the screen. I mean, what the enemy is going to look like. They are going to be ghost. Okay, what is the draw for the ghost? The player is what? This circle in yellow, etc. And they are inside of a scenario, and there is a score. And that information is not here. We discover that. We add that. We have 2 actors. The actors have not changed. What changes now, we have more actions, more things that they need. The user need to view the maze. The user wants to play inside of a maze. We need a maze. The user wants to have a score. The game has a score. We need the score. The user is the one that wants to be represented as a circle in yellow. The user wants to show itself inside. Well, the user wants to have the Pac-Man inside. You can play with the elements here. If instead of the user here, you put the Pac-Man, view, me, instead of mentioning the Pac-Man, it doesn't matter. You need the maze, the score, yourself, and the enemies. All of this on the screen. I am going to talk more about the relationships, but right now is focus on the circles. All these circles are telling you things that you need, things that are in the game. Moreover, all those circles, if you review with your team, satisfy the invest principles. All of them, independent, negotiable, valuable, can be estimated. You can think about how to develop them. They are small. They are not like program the Pac-Man video game, and they can be tested. All of this is something that you can develop test cases. The Pac-Man is there or not? The ghosts are there or not? I am talking just about view, drawing on the screen. The maze, there is some kind of algorithm that create the mazes. Can I test it independent of the other things? Seems like, yeah, I can have a program that is only doing the maze. I can have another program that is only doing ghost or Pac-Mans. I can test this separate, And in some point, I put everything together, and I can even test integration. Different elements. Obviously, the most important thing that I want to do is the movement. And when I do the movement, if you are in this storyboarding thing, you're going to start talking and thinking about, well, this Pac-Man, this player want to move. Which are all these different scenarios, all the different things that could happen when the user move. Or you are in Canvas and you want to do a quiz. You move to that requirement of quizzes in Canvas, which are all the different things that could happen or that I could need inside of this. I want to do a quiz. I want to move. Things that could be involved. You mentioned this in your documents. Collision, but we need to be clear. Collision with the walls of the maze, collision with the maze. You can use whatever name you want, but the idea is collisions talking about the element, the Pac-Man, and the scenario, the environment. Collisions with the dots, or you can avoid the collision, and it's not a collision, it's eating the dot. Similar idea with the power dot, another kind of dot. Different actions that are going to happen in the system, therefore I put different requirements. For one, it's going to be used increase the score. For the other, it's going to be increase the score, but also the status is going to change, right? Instead of hunting, I am going to be hunted, or the opposite, a collision with the enemy. A different name. Instead of calling collision, let's talk about an attack or die. It's a collision between the Pac-Man and the ghost. Collisions. You cannot have a collision if you are not moving. So they are somehow related with moving. Related, but they are independent. Something is to move, change position X and Y, and something different to do is to compare those X and Y coordinates with the X and Y of other elements. Because at the end, all of these elements have a coordinate, X and Y. The dots, the goats, the walls. And all these requirements is just to compare those numbers. Similar idea with the enemy, the system, whatever. The most important thing is moving. Notice that we already consider the drawing. I can have this guy here, or I can have this guy connected here. It doesn't matter. The requirement is there. The only thing that I need here, and the reason because I have the actors, is to be sure that I do not forget any requirement. That's it. If I put this draw the ghost or view the ghost in one or with the other, doesn't matter. It's there. It's part of my storyboard. Moving, particular, something that you described before is, well, it's not the same moving all of them. We have 4 ghosts and they move in a different way. Important thing is we need to identify the different actors. We have 4, we can identify them for the name. Sometimes if you read, they explain how the different ghosts move, giving the name, Pinky, Blinky, and so on, or just for the color. I have different requirements for moving the ghost, the pink, the blue, and so on, because this implies 4 different algorithms, 4 different implementations, or 4 different programmers working here. Because the moving of the pink is not going to work, it's not going to be useful for moving the red or the blue. I need to consider 4 people, 4 teams, 4 separate projects for creating those 4 algorithms. And somehow discover most of the things that you could need in the Pac-Man. I am going to talk about the lines, don't worry. I am assuming that you reviewed this in 340. Well, those of you that were with me reviewed this, but I am going to provide a summary in the next slide. Wait. The same for the arrows, don't worry. So right now, use the actors and the ovals. And the only thing is, we agree that we have only those 2 actors, whatever is the name, user, Pac-Man, system, ghost, enemy. And we agree that these ovals satisfy the invest these ovals explain the storyboard in a big picture for the Pac-Man? Maybe. However, a lot of the things that I mentioned that was wrong in your assignment, a lot of the things that we reviewed in the previous lecture, have one particular problem. You start with the storyboard. From the storyboard, you do a brainstorming of ideas. From the brainstorming of ideas, you go and you can create this diagram to represent your actors and your requirements. But what happened in your homework? Well, the usual. We are here, and suddenly we go down, and because we asked for small and independent, well, we go to one line of code. We go with things that can be described like one line, such as increase the score. Some of you mentioned that is the score need to increase. Play a sound. We review some mentions of, well, the Pac-Man is dying, then play a sound, or is eating, play a sound. A common mistake is you're trying to do the storyboard, you're trying to understand the problem, and at the beginning, it's like very, very hard, and we are in a scenario like this, but suddenly we are not only here, but talking about this kind of stuff. Things that are too small, too specific, things that are instructions in the program. One instruction, one line, one variable that is going to change the value, one command that we're going to call, something very, very specific that are the activities or the steps. This should not be ovals in the diagrams, not in the use case diagrams. The question that you could have is, how do I know that something, some idea here is not a requirement, but an activity, a step, an instruction? Well, something that you review in 360 is use case diagrams, but something else that you review in 360 is activity diagrams. In the use case diagrams, you have the ovals. In the activity diagram, you have the conditions and the activities, and well, things that could happen in parallel. But the important ones, conditions and steps, requirements. The first thing that you need to think is, okay, I have this idea. I have this line. Should I put that line in a novel, in a use case diagram? Should I put that in my list of requirements? Is that one a task? Or is use a step in the process? Is just something that could be, should be, is going to be a rectangle in an activity diagram, a step? When you're thinking in a small, this is too small, this is okay. Move down, but not to this point. Task versus step, requirement versus activity. You are doing analysis. You are understanding the problem. You need to ask these questions, and the answer is your experience and the experience of your team. If you are thinking about something that is going to be one line of code, If you're thinking about something that is the value of a variable, that is not a requirement. That is going to be in an activity diagram or a state diagram. Your requirement should be something a little bit more bigger, but not too big. You need to find the balance. Like for the Pac-Man. Wait, are you telling me here to move the pin ghost? But what is exactly the detail? What is the algorithm for moving the pin ghost? You can explain me that in an activity diagram, because the explanation for that includes conditions. If, else. Maybe not a simple one. Conditions. Wait, this one move in a random way. If that move in a random way, that is x equal a random number, y equal a random number. The requirement is to move. Create a random number, x equal to the random number. That is a step. That is something that you are going to put in an activity diagram, or you can represent in an activity diagram. Play a sound. You play a sound when you move the character. You play a sound with the Pac-Man die. You play a sound with eat a dot. It's not a requirement. It's one of these boxes that you are going to put, or you can put in the activity diagram that explain the details of moving, eating, dying. Is use a step. Use one thing in the collection of steps. Good. Now, okay, I can do this, but so far we cover the users and the ovals. The next step, and this next step is something that is going to help you to be sure that your ovals are correct. You are not going to have all the ovals correct at the first time. Even though I am telling you, check that the oval should be there. Check that whatever you put there is not a rectangle. People make mistakes. The next step, I have my users and I have my ovals. Let's identify relationships between the ovals. When we're searching for relationship between the ovals, relationship between the requirements, at this point, step number one, actors. Things that one actor do, things that the other actor do. And the only thing that I am sure you know, or hopefully you know, is you connect the actor and its actions with a line. You know this, right? The actor, the guy. The requirement, the circles. And you connect them, actor and requirements, with a line. A solid line, no arrows, use a line between them. Right? Okay, next. I want to work in the relationships. Relationship between maybe these two guys, or this guy with this guy. Connection between them. How they interact. And here, a big parenthesis for 360 ideas. Parenthesis for 360. I put this in the slides just for you as a reference, but I am going to move forward. Ovals. This is a requirement. This is what we call use case. Actors. These guys. What we explained before. Relationships. These two guys connected with a line, like we showed. But between the requirements, there are three possibilities of relationship. Three possible connections that you can represent between ovals. One, inheritance. Inheritance, solid line and a triangle as an arrowhead. That is going to be inheritance between requirements. Help me, what is inheritance when you use inheritance? Any idea?
When it's like a subtask of the main task.
Good. You have a main something, a father for something, a general idea of something, and you want to create specializations of that something, childs of that something, details for that something. You use inheritance in your source code. You use inheritance in programming. You can use also inheritance with the requirements. Examples. I am sure that you notice. Inheritance. Makes sense. Inheritance. We're going to move the ghost. And there are 4 different ways to move the ghost. So I have a general idea, moving the ghost, a general requirement for moving the ghost, and 4 specializations. View the character or draw the character. I can have the general idea and I can have the specializations. View or draw the Pac-Man, view or draw the ghost. Again, you're not going to have these circles at the first time. Maybe the first time you think about, you know what? I want to view the Pac-Man. I want to view the ghost. And when you're talking with your team, someone is going to ask, hey, could be a good idea to add a parent here and therefore make these 2 childs? And if so, obviously, like you do with the inheritances, instead of connecting the user with both, can we just connect the user with the parent and the parent represent both? You do not do the parent and the child at the beginning, but it's something that you can move forward and improve. Makes sense? For this scenario, we're going to notice that it's going to make sense. It's going to help us to make this clear, to understand, whatever. Mandatory to use inheritance in all your diagrams? No. Like, it's not mandatory to use inheritance in all your programs. You use inheritance when you think that could help you to better solve the problem. You use inheritance here when you think that could help you to better understand the problem, better explain the problem. And I think that if I tell you that we're going to draw characters and they are the Pac-Man and the ghost, like childs, or we're going to move the ghost and we have 4 options, if I use inheritance, hopefully I am helping to explain better what we're going to do, what are the necessities here. And that is the reason because you follow the inheritance. So a tool, inheritance. You can only do inheritance between ovals. So the father is a requirement, the child is going to be a requirement. You can also do inheritance between users. You can have one actor, and that actor can have inheritance with another actor. Hopefully you agree with me. The only thing that you cannot do, question in your exam, oval, actor. This thing here is correct, yes or no, question in your exam, and hopefully the answer is hopefully you agree with me, do not make any sense. Why an actor is going to be the father of a requirement or why the requirement is going to be the father of the actor. It's not possible, right? Okay, so inheritance only between things that are the same kind. Ovals inherit from ovals, actors inherit from actors. Done. The others. You can have connections with dotted lines and an arrowhead, and those can be inclusion or extension. Notice the difference. Inclusion. You have something and this something includes other elements. Or extension. You have something and I am the extension of the other thing. The arrowhead is very, very, very important. Let me give you an example with something that are not requirements. If I have a car, and I have engine, and I have wheels, they are not requirements. It's just to give the idea. Can we agree that there is a connection between a car and an engine? Can we agree that there is a connection between a car and the wheels? If we were talking about objects and classes, immediately you will react and tell me, yeah, the car has an engine, the car has wheels. The equivalent to that, talking about requirements, is include. A car, include engine. A car, include wheels. Now, if you use include, this connection here is very important to remember the following. It's a very strong connection. When you tell me this, you are telling me that inside of car, here, inside, I have an engine, and inside, I have wheels. That is the meaning of inclusion. Include, have inside the other elements. Moreover, you are telling me that those other elements do not have a use, do not have a reason to exist, but to be components inside of this one. These are just parts, elements, small things. But the big one, the important one, is this one here, inclusion. The big one, the important, is the one that is sending the arrows, and the point of the arrow, the arrowhead, is pointing to the small things, the insignificant things that are inside of the big one. Pointing. The big one is the one pointing. The small ones are the one being pointed. Makes sense? I am going to show you examples, don't worry, but just remember the direction of the arrows and the meanings. Extension. Extension is the opposite. Extension is, you know what? I have a car. And the car includes the engine. So the engine is a small part, and that small part is inside of car, that is the big part. Well, but you know what? I have here a car, and you can figure out any kind of decoration. A car with a flower, a car with a particular additivement. I have something that is a car, but have something irrelevant, something extra. This guy is an extension of car because it's still a car with something else, something irrelevant. And you can create some connection like this. Wait. You're creating this car plus decoration. Why not you just do decoration? And you define that car include the decoration. Two different ideas. Number one, if I do this, if I create a requirement decoration, and if I connect with include, I am telling that decoration is important, mandatory, that you should do the decoration, that having the car with a flower is important. The flower is a primordial component of the car. That is what I am telling here. If I do an extension, what I am telling is, it's a flower. I mean, is something else, something that if you do not have time of doing it, do not do it. Moreover, I am talking about these have low priority, these have high priority. This is important, include extension is, this is not important, this is extra. Well, you're talking about the order of the arrows. Notice this. Always, always, always. If you follow these arrows, you can imagine that you have a tree and the arrows are pointing to the first thing that you need to do, to the most important part to start developing. Here, it doesn't matter if you are doing the car with decoration or the car or the engine. What this is pointing, you following the arrows, doesn't matter include or extend, is the engine is the important one here. It's the first one that you need to do because the engine is going to be a primordial part of the car and it's going to be also part of the car with decoration. The engine is the one that you need to finish. The car is the last element in the tree. Start working there. Once you have that, move up, do the car. The car is the next element that is important. You have the engine, you have the car. Okay, now you can move with the car with decoration. And it's the last one. There is nothing else here. The arrows is telling you, this is important, start here, talking about the requirements. So that is the reason of this arrow here, the base is this one, or the base is this one. You have the base, the important elements, the not important elements when you read it. So this part of intuition, depending on what is intuitive for you. Well, not yet. If you are talking about abstract classes, these are requirements. We are not talking yet about the implementation. That is going to be in the design. The next step is from these diagrams, for the analysis that we're doing, we need to move to the design. And in the design, we're going to decide which of these things become classes, abstract classes, or interfaces. So that is another step.
Okay, thank you for answering that.
Welcome. So right now is this connection of important things, not important things. Notice that the decision that we're taking here, the real decision is you're making a note in a piece of paper, what is important and what is not important. That's it. Usually, and this is a recommendation that I do with the 360 is, if you are not sure about whether or not use include or extend from the textbook, these are the questions that you need to ask. This is optional. The use case, like the car with the flower, if no, is not optional, follow the include. Yes, is optional, follow the extend, and so on. Important, include. Not important, extend. At the center, always the base. Makes sense. So connection between the actor and the use cases, inheritance, include and extend. Examples that we can quickly review. Diagram. The requirements. How many requirements do I have here? Question for your exam, the easy one. How many requirements? 1, 2, 3, 4. 4. Each oval is a requirement, right? 4 ovals, 4 requirements. Good. Okay, 4 requirements. 4 things that I need to do. 4 things that I need to consider here. How many actors? Well, I have this user in general and childs of the user in general. I have administrators, editors, customers. Just like you described before, I have this Canvas user and I can have Canvas user in general, but I can have this specialization professor and student. In the diagram, you know what? We need to do this authentication of the user. The details of web user authentication. The reason because this is a requirement is, well, in order to do this, you are thinking like, I need to do some kind of web page, some kind of graphical user interface in which I am going to ask for maybe the user and the password, and there are going to be other elements involved, whatever. Those are the details. As a requirement, we need to do authentication. And maybe the specification is web authentication. Now, authentication. I have these 3 cases, 3 childs. What is the relationship? Inheritance, special cases of authentication, special cases. Case number 1, the one that I described, the basic one, login. Login, as you understand, is I am going to be asked for my user and I am going to be asked for my password, and there is going to be some place to make click. That is the process. And if I make click correctly, that is a condition. I am going to go to the main page. If I make an error, maybe they are going to ask me again for the user and the password. Maybe I'm going to receive some kind of banner message. Those details, an activity diagram. The activity diagram connected with this login scenario. Well, but if you go to Canvas, not always you provide your login and your password. Not always you are asked for this second step of verification. Sometimes you just select the URL in the browser and you go in immediately. Why? Well, because there are some cookies involved. Because there are this functionality about, do you want the browser to remind your user for a week or more? And that is something that is a special case of user authentication. Is the system need me to authenticate. Sometimes I am going to be asked for this, but in some circumstances, because a cookie or because some kind of feature there, I do not need to do anything. I'm just going to go to this page and I am going to be redirected to the main. Some kind of remember me functionality that you can name whatever you want. But again, the details in an activity diagram, the details of the states, like the user should have selected before remember me in one of the times that login and password was provided. Another option is like, well, we need you to authenticate, but if you do not want to provide a user a password, that you are a user here, maybe there is some kind of guest option. So you just click in some place and you just enter with the credentials of a guest. Inheritance, 3 options for the same authentication of the user. And according with this, the 3 options are available. The 3 options are available for the 3 users, just because the connection. Wait, maybe this guy only can use this one always. Oh, and this one can use all of them. This one can use all of them. And we delete this line. You can play with that. Your lines, the lines that connect the actor with the ovals, are the ones that tell you what is available for who, which actor have an access to what. And just as happened with programming, if you connect with the parent, you have access to all the childs. So in this original diagram, connecting the parent here and the parent here, what you are telling is all these have access to this, and therefore to all of this. When you connect with the parent, the rule is you have access to all the childs. And that works with programming and also with the requirement. Easy. Checkout. The checkout is one requirement. It's just part of the diagram. Checkout in Amazon. You are buying something, you go to the store, you are online, whatever, and you are going to do the checkout. You are going to do the checkout. In this particular scenario, checkout. What is checkout? Well, you know what? checkout, include. Oh, this is like the example with the car. The checkout is just the collection of another thing. Which things? Scan the item in the store, calculate the total and the taxes, and pay. These three are the small things, but they are like the wheels and the engine in the car. Alone, they are useless. Together, they are inside of what we call the checkout. The engine, the wheels together are inside of what we call a car. Include with extend. I want to do a transaction, a bank transaction. This is a scenario with the ATM. Which transaction can I do? Well, you can do a deposit or you can do a withdrawal, but both are transactions. Childs. What is the reason? Because here we create a parent. Only one reason. Because if we remove the parent, we need to make this line connected here and connected here. And we have two lines. And we need to do this line connected here and connected here. And we have 4 lines. If we know that we're going to connect these two guys with the other two, just like in programming, we create a parent, and when we create a parent, we save relationships. We make this easy to read. Bank transactions, withdraw and deposit, good. Moreover, any bank transaction is going to include an authentication. Any car is going to include an engine, or any car is going to include the wheels. There are going to be more, obviously, but it's going to have inside those elements that we're pointing out with inclusion. Wait, extension. Remember, this is the base, and this is an item. The important, the item. When you finish with the item, the base. But optional, if you have time. Did you notice the connection here? The beginning of the arrow. The optional one is, can you add that the bank transactions have some kind of help? Optional. Put help to the ATM. Put something for the user to receive help about what can I do here. Wait, why not you do help here and you connect help with include? Can I do that? Yes, you can do that. What is the difference? What is the difference between this help here inside with extension and this help here in another oval with an inclusion? Do you remember? What is the difference? You can do any of those.
Because help? Oh.
Again, sorry?
I was going to say because help is optional and not required for the base class, and you have to include customer authentication in order to do an ATM transaction.
Yes. Optional, low priority, whatever, you decide. A common question, guys. Which one is correct? This one or this one? What you are doing. You want help to be optional? This one. You want help to be mandatory? This one. What you are telling me in your diagram is your decision. You decide something to be mandatory, you decide something to be optional, you decide something to be a priority, because if I follow this arrow, you are telling me that authentication is priority, after authentication, transactions, 2 transactions, and the last thing to do is to add help. Those are your priorities, or at least what you understand of the priorities of the customer. Your diagram showed that. Another one. Sometimes you are going to have a lot of ovals, and you're going to notice in the textbook and in other sources that you can put a box around ovals. Think about this like a package for classes. You just put borders to enclose some ovals because they correspond to a common functionality or whatever. Boxes include enclosing ovals. To customers, to ovals, they correspond to one subsystem. This customer use both, this customer use both. No relationship between them. Use two requirements. Something more crazy. I have a customer, or I have a child, a registered customer. It doesn't matter which one, both. Remember, when you have inheritance, if the parent do it, the child also. This guy can do order something, food. Ordering food include mandatory, not optional, mandatory, include three things. Optional, an extension, and the options, the extensions, have two childs. So I have two things that are optional. I can, in this system, the requirement of the system is I want a system that allows me to order food. When I order food, I am going to choose what I want from a menu. Which menu I want to show, which item I want, breakfast, what I want, dinner, what I want, and I am going to pay. Three things that I need to do. Optional, when I am choosing a menu, the last thing that you need to do is help me to put filters in the menus, filters, some options that allow me to search quickly. I can do filters according with some diet things, include or not some kind of ingredient, or I can do filters according with some kind of other labels. But this connection here is all of that is the last thing to do. All of that is the optional part. Extension, inclusion, inheritance, and connecting the actors. When you do the diagram, guys, when you do the diagrams and you're thinking about how to connect your ovals, it's a process that helps you to know if your requirements, if the things that you put inside of the circles are really requirements, or maybe they are used on a step. If they should not be here, but maybe they should be in an activity diagram in a different place. So I am giving you with the slides several examples, the ones that you know in 360, and for those of you that take 360 before, something that you can review. Examples, examples, examples. Check the examples and be sure that you understand all those diagrams. Closing the parentheses. Pac-Man, done, at least the big picture. We need to talk about the details. We need to talk about, well, what happened with all these different ways in which the ghost can move. And that means we need to talk about the activity diagrams. And why not also about the state diagrams, because something like the hunter or be hunted or eat or be eaten, this, the normal ghost or not, is depending of one particular value in one particular variable, the state of the ghost or the state of the Pac-Man. And states are values, global variables in your system, attributes in your classes. That is something that we are going to identify later, but from now, we need to represent them. We need to provide this information to the designers. We need to document that some of the requirements involve some particular values in some particular variable that we do not know yet. Some way to represent these different states for the Pac-Man or the enemy, or to represent all these different variations of the movements. We need to talk about activity diagram and state diagram, but that is something that is going to happen later. homework for you, the quiz. And the second one, some of you already did this. I want to be sure that we are all in the same level. So guys, I am asking you to create a use case diagram, applying inheritance, inclusion, and extension. And I am asking you to do that for a system that I describe in these slides, this video. For those of you that take 360 before, is the video that describes your final project. I am asking for the use case diagram of the final project that my students in 360 did before. If you already did it, maybe you can just review and be sure that you did it correctly. And for those of you that didn't take the class, your opportunity to take a look and apply what we reviewed today and create a use case diagram. You have 1 week. It's a teamwork, just like the previous one. Hopefully you can work with the same team that you worked before. 1 week, there is going to be a link on Canvas for submission. The only thing that you submit, a PDF file, 1 page, and that page is your diagram. And in your team, please put your names in one of the corners. That's it, your next homework. So for this one, 1 week. For the quiz, is due tomorrow. Very good question. Guys, this is your project for those of you that take 360. Remember, even if you receive 100 over 100, what the greatest grade was, like in the assignment 1, that you submit something that makes sense. You can submit or use what you submit before as an idea, as a starting point. My recommendation, review the INVEST principles. We do not grade that you follow the INVEST principles for your requirements, because INVEST is something that we didn't review in 360. So it's a good point to start if you already have the diagram, if you already did the project. I am not asking for source code or anything else. Your project was programming. Here I am asking only for the diagram. If you have the diagram, take a look. That can be your starting point. Just review that after what we talked today, you still agree that that is the diagram that is going to be graded. So that's it. Good? Okay, guys, any question? Okay, see you next lecture. Thank you.